Welcome once again to the new calculus channel. My name is John Gabriel. So if you recall, in the previous video I talked about definitions 1 and 2 of book 7 of Euclid's Elements, and so in this video I'm going to continue with definition 3. So let's begin. Now, definition 3 tells us that a fraction, which is otherwise known as a measure, stated in terms of two multiples of the unit, that is p over 1 over q over 1, or simply p over q, that is what is assumed as a fraction. So it's a name. P over q is a name, where p and q mean the following. Q is the number of equal parts of the abstract unit. Now remember, the abstract unit doesn't have a size, but we still, because we are transferring all the properties from book 5 of magnitudes, when we're dealing with the measure of ratios that give rise to fractions, we have to keep those properties in place. And so that's why Q is the number of equal parts of the abstract unit, and P is the enumeration of the said Q equal parts. Now remember, P is the antecedent, right? The antecedent, in this case the numerator, and Q is the consequent, or in this case the denominator. So for example, the number 3 is part of 9 because 3 measures or divides 9 without remainder. In this case, 9 over 3, or simply 3, is the number in question. So the next definition introduces the concept of proper fraction. But once again, the majority of mainstream academics fail to understand the concept of factor and multiple, because in geometry, any magnitude can be a factor or a multiple. This, however, is not the case in algebra, which is a weaker form of geometry. So P is a factor of Q if and only if P measures or divides Q exactly. Okay? And believe it or not, there are some incredibly stupid morons like Zelos Malem from Sweden, who normally hangs out on that news group called Sci.Math, who still doesn't know what is a factor or a multiple. And he's not the only one. So that's definition 3. Now, definition 4 continues on definition 3 and defines a proper fraction. So in other words, a fraction which lies between 1 and minus 1. And how does it do that? It says the lesser is parts of the greater when it does not measure it. So if P over Q is a proper fraction, then P must be smaller than Q. All right? So if P is smaller than Q, then we have what you know today as a proper fraction. So there is a general misconception that P over Q means P divided by Q. It doesn't. P over Q is just a name. The process that is considered to be division or obelisk division, you know, that little vinculum with the 2 dots, one on the top and bottom, by the mainstream is possible only if P is greater than Q. So in algebra, you cannot divide a smaller number by a bigger number. That's just not possible, because by divide, you mean the obelisk division, which is an algorithm where you keep on subtracting the denominator until you have nothing left, or until the remainder is less than the denominator or the divisor. Okay, so now there's no such thing as infinite division. So if P is less than Q, then this operation is not possible in algebra, only in geometry. So you can take any line segment in book 5 and divide it into any number of n equal parts that you like. But in algebra, this operation terminates immediately. Okay, so if you have 1 divided by 3, it stops because 1 is less than 3. There's nothing more to do, right? Essentially, it is a non-operation in algebra where the P is placed on top of the vinculum and the Q on the bottom. Now, this can be done for any P and Q. But if you want to simplify P over Q, which is obelisk division in cases where P is greater than Q, it's a form of simplification and not the actual measure of division. Okay? So, in algebra, when you say 1 divided by 3 is equal to 0.33333, you're not really only dividing there. You're doing a lot more than just dividing. You're trying to measure a third in the radix 10, okay? In other words, you're trying to measure a third in the decimal system, which is impossible because 3 is not a prime factor of 10. Okay, so I think I'll stop here and I'll continue with definition 5 at some future time. I'm John Gabriel. This is a new calculus channel. And before I sign off, if you're not already a subscriber, become a subscriber and spread the news of this channel so that more people can learn this wonderful knowledge and not be hindered by the brainwashing and the indoctrination of the set theorists and topologists and all the stupid math academics in the mainstream. So that's all I have for now. Click like and spread the news. Till next time, goodbye.